Hello, everyone. Just wanted to make a quick video for you to include one last example from section 3.4 that we won't be able to do in class. I'm going to do the last example from projectile motion. This guy, I'm going to do that in class on Friday, but wanted to go through this example here about this bike ride, just in case it's helpful for you. So you decide to take a bike ride. This graph right here is gives your distance from KSU X hours into your bike ride. So you are riding for 3 hours. It's a great bike ride. Um, and part A is tell me about your ride. Okay, so right here at 0, 0, that means at time equals 0, you were 0 distance from KSU, right? 0 kilometers, there we go, away from KSU. And then from 0 until about half an hour, so right for the first half an hour, you rode at a constant speed. Now, how do I know that this section was at a constant speed? Well, if y is distance, then the speed or the velocity, right? Speed is based on velocity. Um, Velocity is the derivative of position. And so since our y value here is distance, which is a position, then the derivative, the rate of change, the slope of this function tells us your velocity. So I know that this first part um, was being ridden at a constant speed because the slope is constant, right? It's a straight line. So for the first half an hour, just make it a fraction here, half an hour, you rode at a constant speed. And then half an hour in, for this next half an hour, right, from half an hour in to 1 hour in, that's another half an hour. For this half an hour, what happened in here? Well, sorry. Well, so in this time, during that second half an hour, you stayed 20 kilometers away from KSU. So for an entire half an hour, you were 20 kilometers away. So then you took a break for half an hour. There was a half an hour in there where you were not moving at all. So you took a little break. And then after that next half an hour, so now we're an hour in, then for the next hour, right, from 1 hour to 2, you rode again at a constant speed because the slope of this is constant. It's a straight line. So then you rode at a constant speed. And how does this speed compare to the one that you started at? Is it faster? Is it slower? How do you know? Well, again, speed is slope, right? So this slope is rise over run, 20 over 1/2, which is going to be 40 kilometers per hour. For this one, our rise over our run is 10 kilometers over 1 hour. That's 10 kilometers an hour. It's a slower speed, right? It's a flatter line. That means it has a smaller slope. That means it's a smaller speed. So for this whole hour, you rode at a constant speed again, but slower than at the beginning. Try to squeeze that in there, for an hour. And then after that hour of riding for a slower speed but constant, now we're at 2 hours in. From 2 to 2.5 hours, again, you stayed 30 kilometers away. Then you took another break. And then what happened? And I also want to point out this whole time you've been riding away from KSU, right? The distance from KSU has been getting larger and larger. And then all of a sudden, here, 2.5 hours in, what happens? You rocket back to campus. So for the last half an hour, you ride at a constant speed back home. Okay. All right. So I know that was a little long, but just wanted to write that out for you. So you rode at a constant speed, you took a break, you rode at a constant speed again, but it was a little slower. You took a break, and then you rode straight back home. Probably because after 2.5 hours, you thought, oh, I have calculus homework to do, and you sped back home to do it. Okay, so part B, calculate the average velocity over the interval from 0 to 2.5. Okay, so if I want to do average velocity. So again, this is a distance function. That's position. Velocity would be the derivative of that, the rate of change of position. This is asking you for average rate of change over the interval from 0 to 2.5. So from 0 to 2.5, we want the slope of that line. So we're just going to use our 2 points, 0, 0, and 2.5. Let's see, the y value there is 30. So we'll use those 2 points and we'll find the slope between them. That will tell us our average rate of change over that period. So our average rate of change is going to be 30 minus 0 over 2.5 minus 0. 30 divided by 2.5. My brain is not going to do that right now. So let me get my calculator out. 30 divided by 2.5 is 12. So that's our average rate of change. It's 12. What are the units here? The units of y, kilometers per unit of x per hour. So your average speed, your average velocity is 12 kilometers per hour. Okay. And then the last one, when were you riding the fastest? Okay, so that when were you riding the fastest? That means when was your speed the biggest, right? Because the bigger the number, the speed, the faster you're going. So when was the speed the biggest? Well, to get speed from this graph, this is a graph of distance. Speed, again, is based on velocity, and velocity is the slope of this graph. This is asking what part of this has the biggest slope. And again, speed doesn't have positive or negative. I want to know what line segment, what part of this is the steepest, either going up or coming down. Which one is the steepest? And the answer is right here. This one is the steepest. Again, we kind of went through this. So this one, this has a slope of 40 kilometers per hour. We did that one in just a bit ago. This one was, let me redo this, 10 over 1. So this had a speed of 10 kilometers per hour. And this one, if we do rise, negative 30 over run 1/2, this has a slope of negative 60 kilometers per hour. So again, the negative part is part of velocity, but speed doesn't have the positive or negative with it. It's the absolute value. So the one of these with the biggest absolute value is 60. It's this guy right here. So you were riding the fastest when you were riding home. You couldn't get wait. You couldn't wait to get back to KSU to do your calc homework. I just know it. Okay. And speaking of calc homework, hopefully that helps you with yours. This is the kind of the last bit that we'll do in section 3.4. We'll do one more problem in class, and then we will move into 3.5. I will see you next time. Have a lovely evening.